Okay, so for our got it problem, we're again looking at the widest to narrowest. So we said that our widest will include our fractions. So our -1/3 x squared will go first. Then our next one to go is going to be our -x squared, because that -x squared has a coefficient of 1. And our narrowest is going to be our 3x squared. Okay, so that's the order they should be in based on their graphs. Okay, moving down to the next page. So the y-axis is going to be the axis of symmetry for graphs of the functions in the form of y equals ax squared plus c. The value of c translates the graph up or down. Okay, so that constant on the outside of an x squared term right here will translate it either up or down based on whether this is a positive or a negative. Okay, so we want to see how the graph of 2x squared plus 3 is different from the graph of just 2x squared. So for our x values, we're just going to use -2, -1, 0, 1, and 2. So when we plug those in, we do 2 times -2 squared, that's just going to give us 8. Okay, and if we do 2 times -2 squared plus 3, that's going to give us 8 plus 3, which is going to give us 11. Okay. When we have 2 times -1 squared, that's just going to give us 2. And if we have 2 times -1 squared plus 3, that's just going to give us 2 plus 3, which is going to be 5. Okay. If we have 2 times 0 squared, that's just going to give us 0. And if we have 2 times 0 squared plus 3, that's going to be 0 plus 3, which is just going to be 3. Okay. If we have 2 times 1 squared, that's going to give us positive 2. And 2 times 1 squared plus 3 is going to give us that 5 again. If you notice, this one and this one are the same. Okay. And if we have 2 times 2 squared plus, nope, not plus, 2 times 2 squared, that's going to give us 8. And 2 times 2 squared plus 3 is going to give us 11. So these are going to be the same as well. Okay, that's the symmetric aspect of it. Okay, so for our original graph, I'm going to use this magenta color. So for our original graph, our vertex is going to be right here. So our vertex is going to be 0, 0. Okay, then if we go to a +1 x value, that's going to give us a +2 y value. Like we said, it's symmetric, so if we go to a -1, we're also going to go up to +2. Okay, we go over to +2 on the y or on the x-axis. We're going to go all the way up to +11, so just one more outside of the graph. Okay, nope, not +11. We're going to go to +8. We're going to go over to up to 8 and graph that. We're going to go over 2 and up to 8 on the other side of the axis as well. And that's going to be what the graph of the original function looks like. Okay. Now, if we go and we graph our function with the +3 on the outside, we are going to start at 0, 3, because that's going to be where our value starts. Okay. Then if we go over 1, we're going to go up to 5. And if we go to -1, we're still going to go up to 5. Okay. Then if we go over 2 on the y-axis, we're going to go all the way up to now. We're going to go up to 11. Same thing, if we go to a -2 on the x-axis, we're going to go up to a +11. Okay. So when we do that, you can see it's just the same graph. We just moved it up 3 units instead of keeping it the same. Okay, so go ahead and work on the got it problem. go ahead and pause, work on the got it problem, and come back and find your answer. For this got it problem, we're going to use the same x values, -2, -1, 0, 1, and 2. So if we have -2 squared, that's just going to give us 4. And if we have -2 squared minus 3, that's just going to give us 4 minus 3, which gives us 1. If we have -1 squared, that's just going to give us a +1. And if we have -1 squared minus 3, that's going to give us a +1 minus 3, which is going to give us a -2. If we do 0 squared, that's just going to give us 0. And 0 squared minus 3 is going to give us a -3. If we do 1 squared, that's going to give us a +1. And 1 squared minus 3 is going to give us 1 minus 3 again, which is just -2. And if we do 2 squared, that's going to give us 4. And 2 squared minus 3 is going to give us that +1 again. So our -2 and +2 should be the same. And our -1 and 1 should be the same. So I'm going to pick different colors again for our original. I'm going to use pink. So we have a vertex of 0, 0, 0, 0. And if we go over 1, we're going to go up 1 and graph it. Over 1, up 1, graph it. Okay. And for our 2, we're going to go over 2 and up 4. We're going to do the same thing on the negative side. We're going to go over to the -2 and up 4. Okay. And we're going to graph it. So it should look like a U. Okay. And if we have this x squared minus 3, our vertex is going to be 0, -3. When we move over 1 on the x-axis, we're going to go down to -2 and graph it. Same thing, if we go to -1 on the x-axis, we're going to go to -2 on the y-axis. Okay, and then if we go over 2, we're going to go up 1 and graph it. And if we go to -2, we're going to go up 1 and graph that as well. So if you notice, it should be the same shape. We've just translated it down the graph by 3 units. Okay? So that should be it for this section.